Okay, now for the second half of lesson 2, we are going to do a bit more on selection. We've used if statements so far. There's one other common type of selection, which is called a switch. We'll get to that in a minute. But before we do, let's talk about pseudocode. I'm sure I can hear a few of you groaning even through this video. But pseudocode is where you try and plan out what you're going to do before you do it. Or alternatively, you can use pseudocode for things like explaining what your code does to somebody else. But we're going to use it to try and plan out our code. So our pseudocode, let's open up Notepad. We can maybe do it in there. Inform the user of the choices, this menu. Get the user's choice from the keyboard. If the user selects Q, then quit the game. If the user selects P, play the game, which is the code we've already got. That's why I modularized it earlier. If you select O, view the options. If the user selects V, then view the high scores. So there's our pseudocode. It's just in plain English, but it's kind of structured. That's why I've got these indents. It uses some words that would be used in code, like the word if. So that's kind of a hallmark of pseudocode. We can actually paste that straight in here. This is called the pseudocode programming process. Very few people actually do it. It's just to demonstrate. Let's make them all into comments. Just to demonstrate the fact that pseudocode should translate roughly into actual code. So inform the user of the choices. That's going to be something like console.writeLine, telling you can select either to quit, play, see the options, or view scores. So that's the done informing the user. Next we get the user choice, console.readLine. Get the key, not readline, sorry, key, and get the key character that was pressed, assign it to a new character called choice. We call it choice anyway. So that's the get user choice done. Why is that coming out red? Semicolon expected. I forgot to put a semicolon in the previous line. Red errors don't always show up on the line that the actual error is. It only gives you a red underline error when it notices something's went wrong. Okay, so if your choice is the letter Q, then WriteLine, bye-bye. And then at the end of it all, you should get a read key, so that will handle that bit. If the choice is P, then we're going to play the game. So let's cut and paste that code in. This is where the modularization that I did earlier was handy. This is why it's a good idea to plan these things ahead. Okay, if your choice is the letter O, then we want to view the options. Now, unlike play game, this was refactored out into a method. We could have typed that in manually, but we refactored it. We could do the same here. We could type in the code and refactor it, or we could make a method manually. But you can also do this. You can also just make up on the fly. Oops. If you don't want it to fill it out, by the way, you need to press escape to get rid of that IntelliSense. Treat it as if it was a method, and then it should be smart enough to realise that we can fix that by generating a method for you. That red line should go away because it's going to add in an options method. It's going to make it crash. That's what this line is doing. It's deliberately crashing the program because you're trying to do something that's not coded yet. But at least now we have this options menu. And finally, if your choice is V to view the scores, we'll do the same thing. And that's us. Q for quit, P for play, O for options, V for view high scores. Our pseudocode has become actual code. That's the idea behind it. So these are what's called method stubs. They're stubby versions of the methods. They're not finished yet. We should go back and finish them later. It's not yet implemented, and that causes an exception, which is a kind of deliberate crash. Or at least it is in this case. Now, what happens though if, while playing the game, somehow this variable gets changed. So we press the P key, and the P key goes in here and it says play game, but somehow during the play game the choice gets changed, and we come back out of this if statement and it's now saying, oh, don't know how that would happen, but it could, and it now views the options as well. So the problem with having multiple if statements is it's possible to run several consequences. Sometimes you want that, sometimes you don't. If you don't, you can just string them all together with else's. Nothing particularly wrong with that either. It means if you choose to quit, do that. If you haven't chosen to quit, then see if you've chosen to play. And if you haven't chosen quit or play, then see if you've chosen to view the options, and so on. So only one of these will now run. A slight improvement. But this happens relatively commonly. So there's a switch you can use to do it instead. You can say switch choice. So choice is the variable that's being inspected, and depending on what value it has, in the case that it has the value Q, we can say console right line by. Let's cut and paste that up here. Every case must have a break to end that case. And then we can move on to the next one, case P to play. And every case has a colon, by the way, not a semicolon, an actual colon. Play game, break, next case for V. I'll just put in a sort of skeleton and cut and paste in later. Options for O. I've done it in the wrong order, haven't I? Never mind. Okay, so play game, VI score, options. My brackets have got severely messed up there. Cut and paste is a programmer's best friend and worst enemy at the same time. Okay, so that's basically doing the same thing. It will inspect this variable and it will switch between only one of these cases, depending on whether the value is Q, P, V, or O. It's not really that different from the else if chain that we had a moment ago, but some people prefer it. It looks a bit more structured, I think. And it is another option you should be aware of at least. Okay, so let's just see it running. And hope that I haven't messed it all up somewhere on the way. So, quit, play, options, or view. If we choose P to play, then there we go. Ready player 1, enter your name, blah blah blah. All the stuff we had working earlier. VI score, excellent. If we chose Q to quit, it says bye bye. And if we choose options or view, they're not implemented yet, so we get an exception, which takes us into debug mode, the yellow line, and you get details of your exception. So whenever your program crashes or hits an exception of any kind, that's what you'll see. Alright, so that's actually lesson 2 finished. Let's do the recap on it now. So this one's about sequence and selection. Before I get there though, we should talk a little bit about problem analysis. There's every time you create a new game, it's a problem because nobody knows exactly what to do, not the exact details of every little bit of it, so that's a problem. That's what they call a problem anyway. If your software does nothing new, then you're not going to really sell it. You know, if you make the exact same game as Flappy Bird, literally exactly the same, it's not going to do well. So there's always a problem to be solved. So you need to come up with a solution, and the first step in doing that is to analyse the problem. And analysis of problems is a very big field. I don't have time to even touch on it very much. But the short version is you need to come up with a list of requirements for your product so that you can analyse whether you've met those requirements later on. One thing that can help you do that is pseudocode, which was mentioned earlier. You could just start coding, but that tends to result in messy, unorganised code. It makes it really difficult to maintain and debug. It's better to plan your code out. It's much more efficient in the long run. So pseudocode is one way to do that, also called structured English because it looks like English, but it's structured like code. So it's halfway in between, which should help you turn it into actual code. Now here's another example. Most games follow this kind of structure. Load in the media and then repeat this over and over. This is called the frame loop or game loop. So in every frame of the game, we get input from the player, process the AI, handle any physics that are involved, update the game objects, move them around, whatever that entails. and then draw the screen on the video. And it will repeat that until the player chooses to quit, however that, or game over, or whatever it is to cause the game to end. And once the game's finished, we release the stuff from memory. So pretty much every game follows a pattern more or less like that. In fact, it's so common that when we get to monogame, a lot of that will be done for you. The loop, there'll be a place to load graphics, there'll be a place to unload graphics, and so on. We mentioned string handling. You saw concatenation in action using the plus symbol, but there's also things like trim to get rid of characters at the end, empty characters or wasted characters. You can insert characters in, you can remove characters, you can take out the middle part of a string, like if you wanted only a few letters from that string there, that would be a substring. You can do search and replace, you can check if it contains things. And loads more. These are just examples. String handling is not the most common thing to do in games though, so that's why we've not talked too much about that. Here's an example of concatenation, adding on a string variable onto two string literals. Converting data we did. When you've got two variables in different formats, you may need, for example, an integer and a floating point to work together. Normally you can't use it together if it's the wrong type, but you can convert it using a cast. Sometimes it's implicit, it's done for you. For example, if you're lucky, the compiler will do it for you. It will do that if there's more room in the variable type you're going into. For example, floating points can store much bigger numbers, billions and trillions instead of, I think it's 2 billion for an integer. So if you can assign an integer value to a float, it doesn't cause a problem. But if you try and assign a float value to an integer, that's why it does cause a problem. There's no space for it. When this can happen, it's called implicit casting, because you don't do it. It's implied. So here's an example. If you've got a score integer, you can assign that integer to a floating point, but not the other way around, hence the red error. But when that happens, you can do it explicitly. You can do it. Type it in by hand using the cast operator. Not everything can be casted. For example, you can't cast a string, that's why you have to use the convert class. So same thing here, but the way to do it is to put an integer cast in to turn the floating point into an integer before assigning it. You can convert things without casting. You can do it manually, or you can sometimes use the convert class, as I said earlier. So for example, if we take the string of text 69, no idea why that number's there, and try and just cast it to an integer, it won't let you do that. It's an error. But if instead you pass that as a parameter to the conversion method, it'll then give you a number and you can store it. So flow control is what we've been all about. Here's an overview of flow control. Code isn't just one big lump that runs all at once. Commands need to execute in a certain order. And you can control that order by using these three methods: sequence, selection, iteration. Sequence, as we've seen, just means one command after another. If it was a flowchart, it'd look pretty simple, top to bottom. Selection means choosing whether or not to execute certain lines of code. So you've got some kind of condition that gets checked, and if that condition is true, execution branches off to some other part before coming back to join the main trunk of the code. If the condition is false, it doesn't branch, it just continues on. The third one, iteration, we'll see later. You start off with some kind of commands and then you check the condition. If that condition is true, then you run out the body of the loop, and the loop then advances before checking the condition again. Eventually, that condition will hopefully become false. If it doesn't become false, you're stuck in this loop forever, and that's your program frozen. But if it does become false, then it continues on with the rest of your code. We'll see that later, as I said. So the if statement is the basic branch, and it's what we saw earlier. You check the condition. If it's true, you run the consequent. If it's not, you just continue on. Here's an example. So the condition is the thing inside the parentheses. If lives is less than 1, game over equals true. So it evaluates this here. If the number lives is less than 1, that comes back true, which means the code does execute. If lives is not less than 1, that comes back with a false value, it evaluates to false, and the code does not execute. That code is called the consequent, that block of code, or it can be a single line if you want. I try to avoid that because it can get a bit messy, but you can skip these curly brackets if it's only one line you want to run. So this is a basic if statement with a condition and a consequent. The else statement is kind of like two if statements together. You might want this if you've got two pieces of code. You run one and not the other. So these two are sort of the same. If lives is less than 1, game over is true. Else, the timer goes up by 1. So it's going to do one of those but not the other. You can do it this way as well. You can just say if lives is less than 1, game over is true. Or if lives is not less than 1, greater than or equal to 1. Then the timer goes up by 1. If you're not careful, that can suffer from the same problem I said earlier, where sometimes the consequent can modify the condition and it ends up running both if statements at once. So I tend to prefer if else where it's feasible. Nesting is where you have one condition inside another, one conditional block. So for example, if you run out of lives, then game over becomes true, but also we then check if you've beaten the high score. So that check only happens when you've run out of lives. Nesting is very powerful, but it's also very easy to get it wrong. If you put something nested inside the wrong part, you can very easily have things going at the wrong speed, or never happening at all, or just plain crashing. Then there's the switch statement, which evaluates an expression. Actually, I think that might be a mistake there. I don't know if this can be an expression. I think it has to be a variable or a value. But anyway, switch based on this variable. In the case that level is 1, it runs this spawn. In the case the level is 2, it runs this spawn. It's more or less, it's almost the same as saying this. If level is 1, spawn at the door, else check if level is 2, then spawn at the staircase. As you can see, switch is just a bit more efficient. So that's all the sort of technical code we've learned in this lesson, but we should also talk about some of the things that were kind of implied, the conventions of the way we coded. Because you can write the same code lots of different ways. You can use standards in an organization, and there's lots of conventions that an organization can choose to use as its standards. It specifies stuff like when to put comments in, what should go in them, how much indentation to use, what to call your variables, where you should put your brackets, how much space you should use, etc, etc, etc. It's a very big topic. I'm just going to go over some basics just now. I tend to use camel case, and Microsoft uses that for variables and lots of other things, but not everything, confusingly. I tend to use camel case for a lot of things. I tend to use camel case for everything, but Microsoft doesn't use camel case for everything. Camel case means identifiers can have multiple words in them, but each word, except for the first one, has its first letter capitalized. For example, high score, capital S, player name, capital N, game over, capital O. Microsoft does the same, but for some methods and other things, the first letter is capitalized. That's called Pascal case, which is very slightly different. As long as you're consistent, it doesn't really matter what you use. Now, the next thing is placement of brackets. There's a lot of argument over whether the bracket should go at the end of a condition or on a line on its own. I tend to prefer the second one. It is up to you. There's also other ways you can do it, but they just make your code look obfuscated, and they're generally frowned upon. So it's one or the other. Another example is spacing. Almost everyone puts a space in between methods. Some people put spaces in between identifier types. Some people put spaces in between chunks of code. Some people put multiple spaces in. I tend not to do that, but some people do. It's a matter of personal choice or organizational standards for the spacing again. Okay, now the last thing is the operators, which we've used quite a few of them now. It's time to lay them all out, I think. So here's a rundown of the most important ones. First, the primary operators, the ones that happen first. The member access we mentioned way back at the start is a dot. For example, if you want a sprite batch to access the begin method within it, use the dot in between. Indexes we'll get to later. Square brackets or braces are used to indicate an index in an array. Increment or decrement, plus or minus means you add 1 or subtract 1 to a variable. It's so common to add or subtract just 1 that it's got its own command. It's basically the same as saying x equals x plus 1 or x equals x minus 1. When you want to create a new object, use the operator called new. For example, if you want to make a new vector, well, you use the word new vector 2. There are arithmetic operators like add, subtract, multiply and divide. There's also a modulus, which means you do a division but you take the remainder rather than the quotient. And these can also be used in assignments. So the basic assignment is just an equals sign, x equals 10. But you can also do a compound assignment by adding on 10 to x, subtracting 10 from x, multiplying x by 2 or dividing x by 3, for example. The relational operators are to do with comparisons. So check if two operators are equal. That's two equal signs. Again, very easy to get mixed up. If x is equal to y. The opposite is, of course, not equal, which is indicated by the exclamation mark. So not equal to, x not equal to y. You've got less than, greater than, less than or equal, greater than or equal. But you can also combine multiple things together with ands and ors. So for example, if x is equal to y and x is greater than 2. You could say, use the or. If, that, by the way, that's a double pipe symbol, which is usually next to the Z on your keyboard. So if x is not equal to y, or x is less than or equal to 10. So we combined two expressions there. A single exclamation mark on its own is a not, which basically inverts a true into a false. So game over, not game over means if game over is true, you'll get false. If game over is false, you'll get true. And that's it for now.